All right, let's get right into it. Something truly historic is on the horizon for 2026. And no, it's not some flashy new gadget. It's a massive shift happening kind of under the radar inside the world's data centers and factories. And it's all being driven by one thing: artificial intelligence.
And this is the number that really puts it all into perspective. The global semiconductor market is about to cross $1 trillion. Now, here's the incredible part. This isn't your usual upgrade cycle for phones or PCs. This boom is being fueled almost completely by the ravenous appetite of AI.
That's why you have to understand, this is not business as usual. It's what the industry is calling a supercycle, a complete rewrite of the rules of the game, where the stakes are, frankly, enormous. We are talking about who will literally build and own the physical foundation of our future.
You see, AI isn't just some magic code floating around in the cloud. It has a real physical footprint. It needs a massive foundation of silicon, of memory, and just colossal amounts of power, all on a scale that we've never even tried to build before.
Just take a look at these numbers projected for 2026. I mean, they're staggering. The hyperscalers, that's your Googles, Microsofts, Amazons, they're on track to spend $500 billion. The memory market is expected to shoot past $440 billion. And a crucial slice of that, high bandwidth memory, is set to explode to over $54 billion. Every single AI tool you touch rests on a mountain of hardware that these numbers represent.
So the big question is, how do you actually win in this new era? Well, it turns out leadership in 2026 isn't about having just one cool piece of tech. It all comes down to mastering three very specific, absolutely non-negotiable technologies. If you fail at even one of them, you're out of the game.
The entire AI hardware world is built on these three pillars. First, the jump to 2-nanometer chips. Second, the incredibly complex art of advanced packaging. And third, the absolute necessity of something called high bandwidth memory, or HBM. So let's break down what each of these really means. Okay, first up, 2-nanometer chips. Now you might think this is all about making things faster, right? But that's not the whole story. The real breakthrough here is cutting power use by up to 30%. In a world where data centers are literally running out of electricity, this isn't a race for speed, it's a fight for survival.
The second pillar, advanced packaging, is where the game has totally changed. For decades, the hardest part of making a chip was actually fabricating the silicon wafer. Not anymore. See, today's monster AI chips are actually made of smaller chiplets, like a city of tiny chips that have to be stitched together perfectly. And that assembly process, the packaging, is now the biggest bottleneck in the whole system.
And the final pillar is HBM. Look, you can have the most powerful processor on the planet, but AI models are incredibly hungry for data. They don't just starve for processing power, they starve for memory bandwidth. HBM is the super fast fuel they need to even work, and its supply is controlled by just a few key companies. So, with those three pillars as our foundation, the stage is set for a massive showdown. This new chip war isn't just about who has the best engineers. It's about strategy, about alliances, and it's a brutal fight for control. And in this fight, one of the most powerful players is a company you might not even know. They don't make the big-name GPUs, but they control something just as vital: the supply of that high-bandwidth memory we were just talking about. This chart just says it all. SK Hynix has a death grip on the HBM market, controlling somewhere around 65% of it. And here's why that matters. Without them, the grand plans of NVIDIA, AMD, even Google, they could all just grind to a halt. In this race, if you control the memory, you control the game.
Now, nowhere is this battle more obvious than between the giants NVIDIA and AMD. And what's fascinating is that they're taking completely different strategic bets. NVIDIA, knowing all about those power limits, is focusing its next big platform on efficiency, getting more performance for every watt of power. AMD, on the other hand, is attacking on the memory front, loading up its GPUs with more HBM to win over data-heavy scientific computing. This is a war on multiple fronts.
But wait, it's not just a two-horse race. The biggest customers, those cloud giants, are getting really tired of depending on one supplier and paying what's being called the NVIDIA tax. So, they've started a rebellion.
They're now building their own custom AI chips. You've got Google with its DPUs, Amazon has Trainium, Microsoft is building Maya, and even Meta is in on the action. The goal here isn't to sell these to you and me. The goal is to control their own destiny, to manage costs, to optimize for their needs, and most importantly, to manage power.
And the rebellion doesn't end there. We're seeing another huge trend emerge.
The realization that a one-size-fits-all GPU isn't always the best answer. And that has opened the door for a whole new wave of specialized hardware startups.
You've got companies like Cerebras building these absolute monster chips. I mean, they're the size of a dinner plate designed for huge scientific models. Then you have Grok building chips for incredibly low latency, which is crucial for real-time AI. They're proving that sometimes being specialized is a massive advantage.
But, and this is a huge but, all of these players, the giants, the rebels, the specialists, are all hurtling towards the exact same immovable wall. It's a fundamental physical limit that is going to define this entire war.
So what do you think that is? What's the one crisis that could stop this whole trillion-dollar supercycle right in its tracks?
It's not a lack of silicon. The industry is brilliant at solving that. And it is certainly not a lack of money. We've already seen the mind-boggling figures. No, the real problem is something much, much more basic.
It's electricity, just raw power. Data centers are already using a huge chunk of the world's power, and that demand is expected to triple in just a few short years. Our power grids were simply never designed for this kind of intense, exponential growth. This is the Great Energy Wall, and it changes everything about this race.
Because as soon as you hit that wall, the rules of the game change completely. The single most important metric is no longer raw power. It becomes efficient power, TOPS per watt, trillions of operations per second. For every watt of electricity you use, that becomes king. All of a sudden, efficiency isn't just a nice feature, it's the whole ballgame.
So when we look toward 2026, the new rules for winning are crystal clear. It's not going to be the company with the fastest chip on paper. It's going to be the one that controls the memory supply, masters the art of packaging, and, most importantly, designs the hardware that can smash right through that energy wall. Because at the end of the day, this isn't just a story about corporations and market share. This is a story about fundamental physics. The real AI war is a battle against the laws of thermodynamics, a desperate fight for efficiency fought with individual atoms on the smallest scale imaginable.